Hello everyone, welcome to my build tutorial on the Estes Vapor rocket. Before we get started, I wanted to go over a couple notes in regards to selecting a motor for the rocket. I think this is a good rocket if you haven't flown a composite reloadable motor before to fly your first reloadable motor in. It's just a great transition rocket. So if you've only flown Estes motors before, there's two other videos on my channel that you probably want to reference before buying your motor for this rocket or flying your rocket. The first is called How to Read Thrust Curves, which will help you kind of predict the performance of your rocket based on the performance of the motor and know what the flight's going to look like. And the other one is how to assemble a reload for the 24/40 reloadable motor system. I walked through all the steps in assembling an F12 reload. Now, I don't know that I fully recommend doing an F12 reload for this rocket, but there are two other reloads in that motor system, the F39 and the F24, which I do recommend. So make sure you reference those videos before buying your motor or selecting your motor for flight for this rocket, because this rocket presents an excellent opportunity to take your rocketry skills to the next level by flying a reloadable motor. And these are what the thumbnails look like for those two videos. Let's begin with the motor mount assembly, which houses the motor inside the rocket and consists of a motor mount tube and 4 centering rings. The motor fits inside the motor mount tube, and the centering rings support the motor mount tube inside the body tube or the airframe of the rocket. The centering ring material and the bonds between the centering rings and motor mount tube and centering rings and body tube must be strong enough to hold the motor in place as the rocket launches. This is of concern because we are going to be flying this rocket on motors with higher peak thrust than the rocket was probably intended or designed for. And there's a few steps we're going to take to ensure that the assembly is strong enough to keep that motor situated in place as the rocket takes off. The first and most obvious step is that we're using 4 centering rings, and you really only need 2 centering rings to properly align the motor mount tube with inside the body tube. But with the 4 rings, there's going to be less stress on the rings than if there were only 2, because the load from the motor is going to be distributed to 4 rings instead of 2. Another step we're taking here is the use of wood glue to adhere the centering rings to the motor mount tube and the body tube. And the centering rings are paper-based material that wood glue bonds very well with, so use of the wood glue will provide extra strength. And further, we're going to use a lot of wood glue for even more strength. So all of these steps taken together should keep the motor mount assembly strong enough to keep that motor in place when we use those higher impulse motors that have a higher peak thrust. Make sure that the 2 rings that are located closest to the ends of the motor mount tube are placed at least a ½ inch away from the end of the motor tube to ensure that excess glue does not seep inside the motor tube upon installation of the motor mount assembly inside the body tube. Now we're going to remove the fins from the fin stock, and the fins are only attached at a few points, which can be broken with the hobby knife for easy removal. And then each edge of the fin needs to be sanded with 220 grit sandpaper to make sure that those points where the fin was originally connected to the fin stock is sanded flat. The most important part of the fin to sand flat is the root edge surface. By root edge, I mean the surface of the fin that is going to be bonded to the tube. As you're sanding, you want to hold the fin up to the tube to make sure that all parts of the surface make contact with the tube and you can't see any light shine through. This is going to maximize the strength of the bond of the fin to the tube. Next, we're going to add a layer of wood glue to the root edge surface of each fin and let it dry completely. this layer of glue is going to seep into the wood and harden, which is going to allow for a stronger bond when we apply more glue that's actually going to be used to adhere the fin to the body tube. One side note about these fins is that the wood grain of the fins is not perpendicular to the axis of the body tube, which is a little bit against standard rocketry practice. But for this particular rocket, that is okay because the fins are very thick, and because of the shape of the fins, that they are long and sleek and swept forward from the aft part of the body tube, that they will take very minimal impact on landing. So this is okay that we're kind of going against the grain on this. These fins are not going to break. Now we are cutting out what is called the fin alignment guide, which is a pre-marked piece of paper that is wrapped around the outside of the body tube and provides alignment for the fins to be spaced 120 degrees apart around the body tube. Now, before making your fin alignment marks on the body tube, make sure that you scuff up the body tube with sandpaper. I use the 220 grit here. What this will do is prepare the surface of the body tube for the bonding of the fins to the body tube as well as the launch lug, and it'll allow for a stronger bond than had you not scuffed the body tube with the sandpaper. Now, when you are taping the fin alignment guide to the body tube, make sure that you use painter's tape. If you use a stronger tape like masking tape or electrical tape, when you go to remove it, it might pull up some of the material on the outside of the tube, which will look bad. So I recommend using painter's tape for this. Also, for your mark for your launch lug, make sure you put some sort of indication that you know that that marking is for the launch lug and not for a fin, so you don't accidentally glue your fins on in the wrong place. Next, you are going to connect your two alignment marks from the fin alignment guide together with a straight edge, which will provide a line for you to see when you're installing the fin onto the body tube. Now, to do this, I highly recommend using an angular piece of metal or angle iron like you see me using here. Now, tradition has you using a door frame or lining up your body tube against a door frame to make this mark or to make this line, which does work. However, once I got this angular angle iron, I never went back to using the door frame. It's just a far easier and superior method, and I highly recommend you getting this tool for building your rockets. Now we are going to put a very thin and smooth layer of wood glue over our lines that we drew for our fin installation on the body tube. This kind of serves the same purpose as putting that layer on the root edge surface of the fins that we did. It's just good practice for making a stronger bond. Now, if we were going for really high performance with this rocket, or by that I mean really high speed, if we were going to fly it really fast, the bond between the fin and the body tube would definitely be of utmost importance, because this is the failure mechanism by which most high performance rockets fail when they're going for altitude records or trying to go really super fast. And the reason I bring that up is that the design, or by that I mean the geometry of this rocket, is not much like most lower mid-power rockets. It looks more like a high performance rocket that you make completely out of fiberglass or carbon fiber and try to set an altitude record with at the Black Rock Desert. It just doesn't look like a lower mid-power rocket. It looks like a high performance, high power rocket. So that's why I bring that up. Okay, back to the construction part of the rocket. Here I'm putting a bead of glue around the joint between the centering ring and the motor tube. This is basically on the sides of the centering rings that I didn't do when we first glued the centering rings onto the motor mount tube. I like to make sure I get glue on both sides of the rings for strength. And now we're going to glue the motor mount assembly inside the body tube. So here you want to use a lot of glue that's evenly distributed around the inside diameter of the body tube. But at the same time, don't use too much glue for two reasons. One is that it won't dry all the way, and the other is that you don't want to get any glue inside your motor mount tube. So after you install your motor mount assembly inside of the body tube, make sure that you did not get any glue inside of the motor mount tube, and also make sure that you set the body tube, vertically for when it dries, so that the glue is evenly distributed and that it doesn't leak into the inside of the motor mount tube. Now we are going to glue the fins on the rocket. The way I like to do it is to put a layer of glue over the line for each fin and let it partially dry so that when I stick the fins to the body tube, they actually stick to it and stay. So really that's the main point here, is that you glue them on all at once, but also make sure that the glue is a little bit dry, or partially dry, before you stick them onto the tube so that they don't fall off when you're trying to get them aligned. Now the next thing we are going to do is glue the launch lug onto the rocket. Now, the instructions say that you should cut the launch lug in half and glue it to the rocket in two pieces, which in general is good because you will have a longer section of the rocket aligned with the launch rod. However, the launch lug that is supplied with this rocket kit is very thin and has a very small inside diameter relative to the outside diameter of the launch rod. So what I mean here is that if you are to follow the instructions and to split this launch lug in half, you need to ensure that your tube is extremely smooth and that you have extremely good alignment of the two launch lug pieces, which may or may not be achievable without a whole lot of effort or a whole lot of attempts. My recommendation is to just keep the launch lug in one piece and glue it on the rocket as you see me doing here. It might not fly quite as straight as if you broke it up into two pieces. However, you will avoid going to the rocket launch and finding out that your rocket will not actually fit on the launch rod and be unable to launch it. So the way you see me doing it here is kind of the easy way out, and is definitely the way I recommend. So a couple tips when gluing the launch lug to the rocket. The first is to make sure that your bead of glue that you apply to the body tube is not longer than the launch lug itself, because if it is, then excess glue could get inside the launch lug and you'll have to remove it and clean it out and start all over again. And the other tip is, when you glue the launch lug to the rocket and you're waiting for it to dry, make sure you do a visual inspection from multiple angles to check for alignment of the launch lug with the axis of the body tube, because sometimes if you're looking at it just from one way, your eyes can kind of play tricks on you, and it turns out that the launch lug is not perfectly aligned, and you will probably have to glue another launch lug onto the rocket, which is something you don't want to have to do. So try to look at it from a bunch of different angles to make sure that you get it right the first time. I know I'm a little bit behind on the narration here, but really all we've been seeing me do here is put some fillets, wood glue fillets, between the fins and the body tube, and there's not much to say about it, just try to do it like you see here in the video. And now I'm going to add some epoxy fillets to the launch lug body tube joint. Be careful here not to get too much epoxy near the ends of the launch lug again, because we don't want it to seep inside of the launch lug. Now you've probably already noted that for bonding the launch lug to the body tube, I'm using Elmer's glue wall and epoxy instead of using wood glue like I used on a lot of the rest of the rocket. And the reason for that is because I'm not sure that the launch lug bonding surface is paper or wood based. And I know that the Elmer's glue wall, when it's in its liquid form, and the epoxy too, when it's in its liquid form, is attracted to a lot of different material types and not just wood, because when you're using an adhesive, you want to make sure that it's more attracted to the material that you're bonding than it is to itself, or else it won't seep into all the nook and crannies of the materials and form a very strong joint. So that's why I didn't use the wood glue here. Leave in the comments if there's alternate adhesives you can use besides epoxy, because I don't like to use it if I don't have to, because it's just messy and not really as enjoyable to work with as wood glue, because I can put my fingers in wood glue and mold it and sculpt it however I want, but with epoxy I'd have to use gloves for that. Here I am assembling the shock cord mount, which secures the shock cord to the forward end of the airframe or the body tube. And this mount assembly doesn't look very strong, but actually it is. The last two Estes rockets that I've flown that have had a separation between the nose cone and the body tube, by that I mean the two pieces fell to the ground separately, the shock cord mount was perfectly intact inside of the rocket, and it was the actual shock cord itself that had severed or failed. And so, yeah, it doesn't look strong, but it is. Now I'm going to apply another epoxy fillet to the launch lug. This will be on the side opposite of that which I applied the first fillet to. And next I'm going to do some touching up of the fillets on the fins. I'm going to cut off some of the excess wood glue and add a little more where I thought there wasn't complete coverage. And after this, the rocket is basically ready to go ahead and paint. Soon you will see a slideshow of pictures from the painting process. Alright, now let's get going with cutting out the decals. Now there's actually two sets of decals for this rocket because there's two different color schemes or paint schemes that you can use, and obviously the one I chose was the black and yellow scheme. And I want to note, when you're cutting out these decals, make sure not to accidentally cut through the decal you're not intending to cut through, because the decals are all placed very close together on the sheet, and also you're going to have to cut really close to the color area of each decal, because you need to make sure that the decal is not too big to fit in its allotted space on the rocket. So I actually had quite a bit of difficulty with putting the decals on the fins, because we didn't seal the fins off with any sort of glue or sanding sealer, or by gluing paper on top of the fins, which was probably not a good choice for this rocket. And the reason I say that is because when applying the decals, the sharp points on the wood actually cut through the decal, which made putting on the decals significantly harder than it should have been. Okay, so there I just added some more glue to the inside of the rocket with the goal of strengthening the motor mount assembly, or the bond between the motor mount assembly and the body tube. Be sure not to get excess glue inside the motor mount tube here, which will happen if you use too much glue. Next, we're going to glue the shock cord mount into the forward end of that upper body tube, make sure that you apply the glue the same way you see me doing here in the video, because you don't want to use so much glue that there's too much excess and that you accidentally glue your finger inside the rocket, or that you don't use enough and the bond is not strong. Then the other point here is to make sure you hold it in there long enough with your finger to allow the glue to set, because you don't want to have to do this twice. Okay, while we're watching this dry, I did want to take a second to discuss the center of gravity of the rocket in relation to the center of pressure, because I do believe that with all of the glue and the use of the 4 centering rings in the motor mount assembly, that our rocket is a little bit heavier on the aft side than the design intent. If you couple that with the fact that we might be flying it on higher impulse or bigger motors than the design intent, that we might need to add some clay to the nose cone to move the center of gravity forward up towards the nose cone. And I'm probably going to include that in a later video once I'm about to fly the rocket and know what motor I'm going to fly it on. Just wanted to keep that in the back of your mind before flying the rocket. So here's the parachute that came with the rocket. Needless to say, it's enormous and, in my opinion, way too big for this rocket. Regardless, I go ahead and cut out the spill hole with the intent that I might use it, although I really can't see myself using a parachute this big for this rocket, especially since, like I was saying earlier, the design of the fins, they're swept forward, so basically those fins are not going to break, so there is really no need to use such a giant parachute for this rocket. I'm probably going to take a smaller parachute from a different rocket to fly with it. So here, like I do with most all of my Estes rockets, I'm increasing the length of the shock cord, or really I'm adding an additional piece of shock cord, and what this does is it reduces the stress on the recovery system upon parachute deployment, and it's just good practice. There's no reason not to do it. It really increases your chances of a successful recovery and keeping your parachute and nose cone with the rest of the rocket. Next, I'm going to add some more glue to the motor mount assembly for strength. I do want to note that I do not intend to use the plastic motor retainer that was included with the rocket kit, because when I did a little preliminary stack up, it didn't look like it was going to work with my 24/40 reloadable motor, but I'm not saying for sure that it won't. So if somebody has used one of these motor retainers with a 24/40 reloadable motor, please leave that in the comments, and maybe I can be convinced to insert it later or to add it to a different rocket to see how it works. The main concern with it, as with all motor retention systems, is going to be to ensure that there's some level of distance between the motor and the blast deflector, because you don't want the flame from the motor deflecting back into the rocket and burning up your motor retention feature, which is one of the main root causes of reasons that motors eject out the back of the rocket and motor retention systems fail. Now I will show how I attach the parachute to the shock cord for instructional purposes. I do want to note that before flying the rocket, make sure you add talcum powder to the parachute. As you see in my Cherokee E build tutorial video, shows how I add the talcum powder. So you want to make sure you add talcum powder to ensure that the parachute opens smoothly. And the last step for this build tutorial will be gluing the lower and upper body tubes together. And that is all. Thanks for watching, and be sure to subscribe.